vector product or cross product, we can see. That is, we have done earlier, we have done dot product A dot B, and now the vector or cross product of two non-zero vectors. Non-zero vectors means the vector is not zero. With non-zero vectors A and B is a vector V. It is a vector because dot product is not a vector. It is a vector V defined by vector V is equal to A cross B is equal to mod of A, mod of B, and into sine theta n cap. N cap, what is n cap? N cap, suppose here there are, here, see, these are the two vectors. They are perpendicular to each other. They are the perpendicular to each other. These fingers and these two vectors, and another vector which is coming from here, that is, it is perpendicular to the plane, which is perpendicular to the plane, which is containing, plane containing A vector and B vector. If I want to give you the diagram, suppose here this is a vector A and vector B, vector A and vector B. So they are on the same plane. Two vectors are always on the same plane. So the vector which is perpendicular to the plane, vector which is perpendicular to this plane, this is called n cap. So it is a vector quantity because look here, this is a vector, this is a vector, these are multiplied and everything can be the not vector, and the where n cap is the unit vector. This n cap is a unit vector along with this unit vector perpendicular to the plane containing A, B. Okay, so when A and B are zero vectors, then A cross B is zero vectors. It will be equal to 0. If A vector is A1 I cap, A2 j cap, and A3 k cap, B vector is B1 I cap, B2 j cap, and B3 k cap, then the product of A cross B is A2, why A2 B3? Why A2 B3? Because A2 B3 is that is J and K, the perpendicular vector of that I. Yes, A2 B3 minus A3 B2. That is I cap, I vector I, and A3 B1 minus B3 A1 J cap. Because here, see, sine 0 is 0. So, sine 0 is 0. But here, it is two perpendicular, these are all B2 B3 and A1 B2 minus A3 B1 K cap. So A cross B, I can write it is I cap, J cap, K cap in the determinant form. A1, A2, A3, B1, B2, B3. So I get the same thing back here. Okay, the vector product is not commutative. Vector product or cross product is not commutative. Question number 1. If A vector is 2I vector plus J cap minus K cap, and B vector is I cap minus 2J cap plus 2K cap, then find A cross B and A vector cross B vector, and find, that is, mod of A vector into B vector. Now, solution 1, answer 1. That is A cross B is equal to, I can write, which I have learnt, that is I cap, J cap and K cap. And that is A1, A2, A3, B1, B2, B3. That is equal to I cap, J cap and K cap. That is equal to 2, 1, minus 1. 2, 1, minus 1. And this is 1, minus 2 and plus 2. Then I multiply here. I cap is equal to 2 minus 2. 2 plus minus 2 plus J cap. Sorry, this is minus J cap. Minus J cap is, that is 4 plus 1. 4 plus 1 and plus of K cap is equal to, that is K cap is, that is minus 4 minus 1. That is equal to minus 5 J cap plus minus of 5 K cap. Okay? Okay. It's okay. Therefore, A cross B is equal to minus, that is root over 25, that is 5 square, minus 5 square, plus of 25, that is equal to 50 root 50, that is root 50, that is root 50, that is equal to 5 root 2. This is a scalar quantity, that is 5 root 2. Okay. Find a unit vector perpendicular to two vectors I plus 2j minus k and 2i plus 3j plus k. Now answer is when A and B are two non-zero vectors, let unit vector perpendicular to the two vectors be n cap. So n cap is A cross B divided by mod of A cross B. Now A cross B I j k. This is, I have 1, 2 minus 1, 2, 3, 1. So, and divided by mod of A cross B. So, it is 5i cap minus 3j cap minus k cap divided by A cross B, and it is, this mod of this will be root 35. Therefore, required unit vector is 1 by root 35 into 5i cap minus 3j cap minus k cap.